I would prefer that you don't. I prefer that you just listen. Today we're doing chapters 1 and 2. Chapter 1 was like CSSU and dot plots, and that was pretty much all that was in chapter 1. Chapter 2 is the observational studies and experiments. This is not in your packet, so just listen. If you want to write stuff down somewhere, fine. I would prefer that you just listen. Okay, so chapter 1. One thing was the difference between categorical and numeric or quantitative variables. Numeric is counting, categorical is you're putting them in categories. Within numeric variables, do you guys remember the two types? Discrete and continuous. Which one is the counting and which one's measuring? Continuous is measuring, discrete is counting. A bar chart displays categorical variables only. A dot plot displays numeric. For any visual display, you have to make sure you label the axes, you put scales, and you put a title. There is another chapter that has to do with graphs, so we'll talk about that more. This was pretty much chapter 1, though. Questions, comments? Okay. Chapter 2, sampling. Here's a whole bunch of vocab that you need to know. A census is when you obtain information from the entire population. A lot of times we don't take a census, though we take a sample. Why don't we take a census?
It could be very difficult to actually take a census.
Very difficult in what sense?
If the population is large.
Okay, so if your population is too large, you may be limited by what?
Resources.
Resources like time and money. What is the other example you guys were given in class about why we don't take a census? If it's a destructive process, like when they test cars in car crashes, if you took a census, that means you're going to crash every car. So if the process is destructive, we don't take a census. Do you guys remember the types of bias? Response. What? Confirmation? Selection. So selection, response, non-response, convenience. But bias in general means that you are choosing your sample in a way that the sample differs from the population in a systematic way. So there's something wrong with the process with which you are choosing your sample. It's something that's wrong with the design. So the way to fix bias is not to make your sample bigger, but to fix your method of selection. Sampling frame is a list of all objects or individuals in the population, with or without replacement. You guys know that one? Probably. Okay, and then sample size, you guys know that. Okay, here are the main types of bias. Within selection bias, you have undercoverage and you have volunteer bias. So undercoverage is when you systematically exclude a part of the population. So the one we talked about in class with undercoverage is if you random digit dial. That's undercoverage because you're missing all the people that don't have phones. Okay, this is only important, it's only biased if the excluded group differs on a variable that's important to the study. So one of the questions that you guys did in the book, it talked about random digit dialing to ask people if they have graduated high school. That is an issue because there's reason to believe that people who don't have phones may differ with regards to high school completion than those who do have phones. You understand what I'm saying? Okay, so if my question instead was, what's your favorite color? And I did random digit dialing, is there reason to believe that people who don't have phones differ in their color preferences from those who do have phones?
Yes, poor people are more depressed when they don't have phones. They have darker colors.
No, that's a stretch. I'm just going to say no on that one. And then selection bias, volunteer is a type of selection bias. So that's like when you're at the mall and somebody comes up to you and says, hey, will you fill out this survey for me? That's volunteer bias. Thing to remember about volunteer bias is generally the people who volunteer feel more strongly about the issue than those who don't volunteer. Measurement or response bias means that the method of observation produces inaccurate values. So measurement bias, one type would be like if your scale is messed up that you're using to measure something. Response bias means something with the way that you're collecting the data is influencing people's responses. So like question wording was one of them. So you guys did a few examples where the question was worded in such a way to sway the people who were being surveyed. The appearance of the researcher. So the one we did in class, there was a guy who was asking about legalizing marijuana, and he was all grungy looking, like he had long hair, and I think they were in dreads, and you guys don't remember that? Okay, I've done the question like 5 times, that's how I remember it. So that could affect the way people respond. Non-response bias is different from volunteer bias. Non-response bias is you select your sample and not everybody responds. So this generally happens when you're sending out surveys, like you're mailing them out. Some people are going to mail them back in and some people don't. That is not volunteer bias because you chose the sample. So you chose the sample, but some people did not respond. Whereas volunteer bias, you're just letting whoever wants to respond. Non-response bias has the same issues as volunteer bias in that the people who respond generally feel more strongly about the issue. Do you guys remember what we talked about in terms of if non-response bias happens, how do we combat that? So there was one we did in class about like changing to year-round schooling, and it said that they contacted 500 people in the district, but only 100 people responded. So how would we combat the non-response bias in that case? Or how could we?
You would make it mandatory, or that would be sent home with a piece of paper that asks the parents.
Make it mandatory,
Like in the registration.
included in registration. Can I just send out another 500? What if all of those 500 people respond? Then is it okay? No, because the first sample is still biased when the second one is not. So the way to combat non-response bias is just to follow up generally. So maybe you're going to visit the homes or call the people who didn't respond or something like that. Okay, here are all of your sampling methods. The basic one is a simple random sample. Simple random sample means every sample has an equal chance of being selected. So right now, if I randomly chose 2 females and 2 males, is that a simple random sample? Why not?
Because if you're trying to find 4 people, you give a combination of 3 females and a male. Any combination.
Any combination has to be possible. So it has to be possible for me to choose 4 females. If I choose 2 females, 2 males, that's not allowing every possible combination. 2 females, 2 males would be stratified. So that's where you have strata that are similar, and then you take a simple random sample within each strata. So in this case, I would separate male, female, and then take 2 out of each strata. Note that simple random sample is its own sampling type. These are completely separate. These 4 are not simple random sample types. They're separate sampling types. Cluster is the sampling type that is not super helpful, but this is where your clusters are heterogeneous, so they mirror the population, and then you take a simple random sample of clusters. So here, for stratified, I'm breaking into groups and choosing people from each group. Cluster, I'm breaking into groups and then choosing a few groups as a whole. Do you remember, like at Prospect, what an example of cluster sampling would be? No? Cluster sampling is only used when people are already in clusters. You wouldn't take your sample and break them up into clusters. So can you think of, at Prospect, groups that are heterogeneous? No. That would be stratified. No? Maybe like student groups? Like if you choose sports teams or French club or orchestra, within each of those groups you're going to have people who are all different ages and all different types of classes. The other example of cluster sampling would be like homerooms. We don't have that, but that's homerooms, or that's cluster sampling. Systematic, that's where you have the list and you choose every k person on the list. So maybe you choose every 7th person on the list. You have to have a list though that is not in an order that will affect whatever you're looking at. So let's say that I'm looking at number of hours that students work, and I have a list of students in alphabetical order. Is there reason to believe that alphabetical order has any relationship to the number of hours that you work? No. On the other hand, what if I have a list by age of Prospect students? Is there reason to believe that age might have some relationship to the number of hours that you work? Yeah, probably students who are older maybe work longer. Freshmen probably don't work because they're too young. That would not be a good list to do systematic sampling by then.
So for systematic sampling, would you have to have a random list or randomized list?
It could be organized in some way, but it has to be a way that's not related to the response. And then convenience sampling is exactly what it sounds like. That's the person standing in the mall handing you out surveys. Okay, another thing in chapter 2 is the difference between observational studies and experiments. There are two main differences. First is the difference in design. For an experiment, you assign treatments. For an observational study, you just simply observe what's going on. So the big important word with experiment is treatment. You assign a treatment. The difference in conclusion is what?
Correlation versus
Correlation, causation. Experiment shows causation. Observational study shows correlation. Okay, when can you generalize to an entire population? If it's a random sample. Random sample. Do you remember the one study case that's pretty much completely useless that you get no information from? No, I know it's a very big question. So if you don't have a random sample, you have volunteers. So if you have volunteers, the results of your study only apply to those volunteers. So if you have an observational study with volunteers, that's pretty much useless. You can't generalize and you can't show cause and effect. At any point, if I'm going too fast, stop me. You need to know all of these vocab words. I bolded the ones I thought that you probably didn't remember. Which ones do we not remember? Blocking? Okay, blocking is pretty much exactly the same as stratifying, except stratifying is used for surveys, blocking is used for experiments. So if we were doing an experiment on how fast you can run, what do you think probably affects how fast you can run?
Your height.
Your height? What else?
Wait.
What else? BMI. Your what?
If you're in sports.
If you're in sports. Okay, so an example of blocking, if I'm testing how fast you could run, and it's an experiment, so I'm testing two different shoe types, let's say. One example of blocking would be I put everyone who plays a sport in one block and everyone who doesn't play a sport in another block. Within each block, people randomly get assigned one shoe type or the other. You guys remember that? The example of heights would be I pair you all into blocks. So I choose the two tallest people are one block, the next two are one block, the next two are one block. Within each block, one person randomly gets one shoe and the other person randomly gets the other shoe type. So it's literally pretty much exactly the same as stratifying, except we use the term blocking for experiments. What else do we not remember?
direct control.
What?
Direct control.
Direct control. So for experiments, the one that we looked at in the book and we talked about in class was the waitress who writes thank you on some receipts and she doesn't write thank you on others. And we wanted to see if her tip increased. So one thing that could affect tip besides whether or not she writes thank you is where people are seated in the restaurant. So direct control would be if she only chose 2 booths to use, then where you're sitting can't affect the tip. That makes sense? Do we remember single and double blind? Okay. I know I've told you this about 12 times, but I'm going to say it again because I know some of you are still going to mess it up. Can you give me an example of logistically how a double blind experiment is carried out? A lot of you say, well, double blind isn't possible because nobody knows what's going on. So logistically, how do they carry out a double blind study? Jacob?
In a situation where the experimenter is randomly assigned to an experimentee.
So who knows what's going on?
Just the general data.
Right, so there's one person who's in charge, and then there's a team of doctors, and you all are on 2 different medications, let's say, for blood pressure. Is it possible that these doctors can measure your blood pressure without knowing what medications you're on? Yeah, I'm the only one that knows. Frank, what was the one you were going to say?
Factor.
Factor is just the experimental or the explanatory variable. So like medication or whatever the case may be. Experimental unit is whoever gets the treatment, so a person or whatever the case may be. Do you remember confounding variable? Something that affects the response that we're not controlling for. And then extraneous factor is pretty much exactly the same. We use them interchangeably. Anything else? Okay, so there are 3 requirements for a valid experiment. First one is randomization. What does randomization mean?
Randomly assigning treatments.
Randomly assigning treatments. It does not mean random sample. It means once you have your sample, randomly assigning treatments. Second one is direct control, which we just talked about. Third one is replication. Replication means that each treatment is tried more than once. So for example, if I'm trying 2 different medications, I can't just choose 2 people, give one medication, and give the other one. I need to have more than one person getting each treatment. And then you want to use blocking if it's applicable in the situation. So if there's a logical way to block, you should block, but don't just block just for the fun of it. The way we randomize is normally in a hat. If you're going to use the hat method, what did I tell you you have to make sure you do? Mix the hat. Okay, if you do not mix the slips of paper in the hat, the entire question is bumped down an entire point. So rather than getting a 4, you're going to get a 3 because you didn't mix the slips of paper in a hat. Which is ridiculous, I agree, but I don't grade the test, so. Okay. Designing an experiment. You have to tell me, how am I going to randomize? What are the treatments? What are you going to measure? And then how are you comparing? In this chapter, we didn't yet know hypothesis tests or confidence intervals. Now we do. So when you're talking about how you're going to compare, you need to be specific. So I'm going to do a 2-sample hypothesis test for the difference in population means. Whatever the case may be, you need to be specific. And then a conclusion. You have to be very specific in your design, specific enough so that I can carry it out. And that somebody else can carry out the same experiment. Okay, questions? No? Did I talk too quickly for us?